Now we look at consistent or inconsistent statistics. So two things are there: a parametric function and sample statistics. Do they match or one with the other? That's a question. So in that case, it's consistent statistics. So here we go back to our discussion on problem of specification. See, classic case I can give you is left-handed writing and right-handed writing. Left-handed writing, how many people write? How many people are left-handed writers? Or are these equal? Left-handed writing and right-handed writing. On if we have more samples close to infinity, do we get something like equal number? Or left-hand writing is very uncommon in nature. So why it's a specification issue? Because there's one mathematical formulation that's suitable to what is common events. Say for example, tossing head or tail over many times. Many times we keep on tossing head or tail close to infinite times may yield something like 50 chances of occurring head, 50 chances of occurring tail, 50%. Whereas in the case of left-handed writer, right-handed, same can't be applied because left-hand writing is very unusual in nature. So the same problem happens here. So if we apply the mathematical specification applicable to left-hand writing and right-hand writing, the counting, the same mathematical specification if you apply to tossing the coin, head or tail, over many events, it keeps on repeating almost infinitely, will yield inconsistent statistics. Whereas if we use, say for example, there are mathematical specifications that are suitable to uncommon events. Poisson distribution is a classic case. If you apply that to left-handed writing, right-handed writing, it's consistent. And if you apply binomial distribution to something like head or tail, there's no much inconsistency happening. And the advantage of binomial, if you keep on repeating it, it approximates normal distribution later. Another important aspect is efficiency of statistics. We have two triangles here, blue and green. Look at statistic A with sample size 1000. Here the variance is X. And look at statistics B, again same sample size 1000. Supposing variance is 2X. What is variance? It's any variable minus its mean, and the deviation gets squared, then divide it by number of observations, or number of observation minus 1, and root of the ratio, you get standard deviation. Square the standard deviation, you get variance, and variance is double here. So in such cases efficiency goes down. Therefore, in order to regain the efficiency, sample size should double. In blue, with respect to blue, sample size is 1000, whereas with respect to green, sample size will go up to have the same efficiency. Now coming to another important thing, theory of probability, on which Fisher talks. Broadly speaking, probability is something like chance of an element to be mathematically specified population. That's with respect to population, whereas chance of an element to be in sample, it's sample probability.